Hello, hello. Okay, so hopefully by this time you finish your work sheet. The only thing I will tell you right now, which is kind of awkward because I'm telling you probably maybe before you're racking your brain around it, but now you're watching the video, you get the confirmation. The only thing is that these two are a bit arbitrary. This one, if you didn't know it, it's okay, and then this one, it has the technicality of it having multiple answers. So just bear that in mind. But I promise, like once you see what I'm referring to, it's you're gonna put the dots together. But one and two, we all should have the same work. Okay, so let's start number one. Number one reads, find the equation of the line tangent to f of x of that function at x is equal to 0. Okay, so first thing we want to do is find f of 0, which that's pretty streamlined. It's just going to be 1 minus 0 squared, which is just 1. So that means the point that we're using is 0 comma 1. And then the second part is find the limit. The limit as x goes to 0 for that here m tangent of f of x minus f of 0 over x minus 0. That gets simplified to 1 minus x squared minus 1 over x. Keep in mind, again, this guy over here is your f of x, and just this one is your f of 0. Okay. From here, we have a technical luxury where we can simplify the top. So negative x minus x squared over x, and then we are factoring again, but you can see here that the factoring is super streamlined because just everything has x. So we can just say negative 1 minus x for our limit as x goes to 0. Well, you plug in 0 and you get negative 1. So that's going to be your tangent. And then the last thing for the actual equation, recall the point slope formula and recall the points that we're using. So it's y minus 1 is equal to negative 1 times x minus 0. That gets simplified to negative x and then plus the 1. So negative x plus 1 is your equation of that tangent line at x is equal to 0. Okay. All right. Next prompt. Find the third derivative of f of x, where f of x is equal to 3x squared minus 2. Okie doke. All right. This is going to be fun. I say that a little sarcastically. Let's start off with doing I'm gonna need this for the first derivative. So we're gonna just do that notation quickly. 3x squared plus 6xh plus 3h squared minus 2. Alright, first derivative. The limit as h goes to 0 of f of x plus h, which is 3x squared plus 6xh plus h squared minus 2, and then minus f of x. So minus 3x squared plus 2 all over h. We got some canceling out. 6xh plus h squared over h. That gets simplified to 6x plus h. And then from there, we can just plug in 0 to get 6x. So f prime of x is equal to 6x. Okay? Well, excuse me, what about the second derivative? Second derivative is the limit as h goes to 0. I'm just going to recap the notation. F prime of x plus h minus f prime of h, or I'm sorry, of x over h. Okay. So that's going to be 6 times, or actually, let me just already write the thing. 6x plus 6h minus 6x over h. And that's going to be 6h, I keep writing, limit, over h, and that's going to be 6. And then we know that the limit, substitution, constant value ideas, whatever, that's going to equal 6. So we know that the second derivative is 6. Let's do the third. Now the third is going to look a little odd, but it's important to go over this. So this gets filled in as double prime of x plus h minus f prime, double prime, excuse me, of x over h. Okay? All right. So the weird thing, and maybe you guys started on this part and you stopped here. If you did, that's fine. It's the worksheet, it's not the homework. Um, it's a constant function. So it doesn't matter what you input, irregardless of what you input, it's going to be 6, the output. So technically, the input is 6 minus 6 over h. Now, before we even tackle the limit part of this simplifies to something very trivial. We know 6 minus 6 is just 0 over h. And apart from this limit, we know that 0 divided by anything other than 0 is going to be 0. And here we have the issue of a constant again. But the constant instead of 6 is now 0. This is different than having our 0 divided by 0 idea. We need to make sure that we simplify an expression as much as possible. Because here, especially right here, you can make the accident trick of saying, well, I know plug it in 0. Oh, I'm dividing by 0. Well, that's a fault. But remember, it doesn't count because it was 0 organically. We just simplified. We didn't do any rationalization. We didn't do any dividing by 1 tricks, factoring out tricks of any kind. It just happened to be 0. So please keep that in mind because that does become essentially a trick question. I mean, it's not literally, but if we do this math too quickly, it can come off as one, which is not my intention. But it's still an important, obviously, it's not something we can skip. Okay, so now comes the sort of observation type questions. Okay, number 3. So number 3 says, what do you notice about the functions f of x, f prime of x, f double prime, and f triple prime? What happened to the coefficients and exponents each time you find a derivative? So just to recap, our original function looked like this. Our first derivative looked like this. Our second derivative looked like this. And our third derivative looked like this. Now, this means, what do we see? Now, you could have said a lot of things. You could have said that, the numbers start to disappear, it decreases the power, or we just see that the constant gets bigger. You're allowed to make those kind of assumptions. More or less, I'm gonna give you like the answer, but technically this is like an open-ended question. The answer, or of all the possible observation, is we multiply the exponent power and coefficients to get a derivative, taking one unit off of the power each time. So, the 3 got multiplied by 2 to get 6. The 6 got multiplied by 1 to get 6. The 6, if we do an imaginary x of 0, got multiplied by 0 to get 0. So that's like the overall pattern, but and like I said, this one, like you're not getting, for this problem, you're literally not getting graded for it. It's just like, I need you all to think about it. Similar idea for 4, but this one you should have a more or less right answer. So it says, draw a function, can be continuous or piecewise, with the following characteristics. From from -5 to -3, f of x is a large positive value. From -3 to -1, f of x is a small positive value. From -1 to 1, um, f prime is a small negative value, and then from 1 to 3, f prime is a large negative value. So all this means is that from these points, if it's a large positive value, then that's supposed to imply that the slope is large. But if it's a small positive value from now 3 to 1, that the slope is a small value. And then from -1 to 1, we can do a mirroring if we want. It's a small negative value. And then from 1 to 3, it's a large negative value. So you're supposed to get this sort of a hilly shape. If I were to do a different color just to prove a point, we could see that we would go maybe here, and then maybe just a little bit here. And then if it's piecewise, maybe I drop down here and I go, and I go here from all of these. Let's go ahead and just do some bubbles there for fun. So as long as you got this sort of hilly shape, whether you made it continuous or not, that's going to be the right answer. And it didn't have to be the same. Here, let me draw another one where maybe I'll start here where, maybe this is the large value and then this is the small large value. I mean, this is the small positive value. And then I gave you like a smaller value than this one, and then a big value, but not that much bigger for the negative value. So it's still, you need to see like a whole arc situation happen. The key point I will say is that at -1, we do need to see it go from positive to negative. Or, sorry, I had the urge to make a Pitbull joke. Pitbull? Not the dog, the musician. Okay. Anyway, not the point. Right. Let me know if you guys have any questions. But yeah. I'm gonna start grading as soon as I can, but you I already made you all aware that I'm technically preoccupied, but I don't want to say preoccupied, but I'll get to it. I'll get to it as soon as I can. So I apologize for any delay, but I hope you have patience with me. Let me know if you guys have any questions, and I'll see you all in the next video. Bye bye.